Hey, it's Mason Warren, and I'm here to talk about significant figures. So before we start, we got to get into what is a significant figure. Um, the dictionary defines significant figures as each of the digits in a number that are used to express it to the degree of accuracy starting from the first non-zero digit. So that's a lot of words, but what does that really mean? It's basically just saying that, well, what numbers are important, what numbers aren't important. Right, so any number, the number 1 could have an infinite number of zeros before it, but are those really important? No. And why is any number significant? Um, this could be, this shows that there's more precision in some numbers than there is in other numbers. Like in the case of if you have a analytical balance that reads 4 places behind the decimal, it's far more precise than one that would just read 1 place behind the decimal. So it really plays itself out in science. You see it a lot. So we got rules for significant figures to tell for any number. So to tell if it's a significant figure, you take any number. It can be divided into 2 categories. Right? You have a non-zero. That's anything 1 through 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And those are always significant. And then you have zeros. And zeros can be narrowed down further into 3 subcategories, three different types of zero, if you will. There is a sandwiched zero, and that's a zero like in the number 101. It's got 2 non-zero numbers, one on either side of it. And now there can be sandwich zeros like 1001, where there's 2 zeros, but they're sandwiched by numbers on either side. Those are always significant. And you've got trailing zeros. That's zeros that are after a non-zero. And there's 2 categories of those. There's trailing zeros with a decimal, so that would be like 20.0 or 2000 just with a decimal at the end, you know. And those are also significant. And then you've also got trailing zeros with no decimal. So that's a number like just 2000 without the decimal. Earlier I specified that 2000 with a decimal is significant, but 2000 without a decimal, it's not significant. So like the number 2000, it's only got one significant figure in it. The 2 is the only one that's significant. Then there's leading zeros. So that's a zero that comes before a number. Like I stated in the previous slide, the number 1 has an infinite number of zeros before it, but putting those there doesn't change the number at all. Those aren't significant. Or you have, in the case of a decimal, where it's like 0.0053, the 0.00 before the 5, those are leading and they're not significant. So really the best way to get proficient at significant figures is just to practice. Practice makes perfect, right? Practice is the mother of learning. So in these examples, we're going to have a number, and a number will be highlighted, and you'll say if it's significant or not. We'll talk about why it's significant or why it's not significant. So the number 1. The number 1 is a significant figure because it is a non-zero. Right? Any non-zero is always significant. 101. That's a sandwich zero, so it's going to be significant. 100 with no decimal place. Right? So that's a trailing zero with no decimal, which makes it non-significant. You also have 0.001. That's a leading zero, and those are never significant. And you've got 100.0. So that's a trailing zero, but there is a decimal there. And even if that last zero wasn't on there, so there's the 100.0, even if that last zero wasn't on there, the 100 point, the two zeros and the 100 would still be significant because the decimal's there. So here's some more examples. You can look at the number and tell how many significant figures are in each of the following. If you want to do these on your own, just go ahead and pause the video, do them, and then unpause it, and we can go over the answers. Alright, so we'll look at the first one. The correct answer is 2, because leading zeros, the 4 zeros at the beginning, are leading, and they are never significant. The 5 is a non-zero, so it's significant, and then a trailing 0 with a decimal is also significant. In the second example, 0.5050, you have a 5. The two 5s are both significant because they're non-zeros. You have the first 0 that's a sandwiched between two non-zeros, so it's significant. And you have a trailing 0, and there's a decimal, so trailing zeros are significant. Then you have the number 500, which only the leading number, the 5 in the beginning, it's a non-zero, so it's significant. And then you've got two trailing zeros with no decimal place, so there's only one significant figure. In the last one, you have 5.00 times 10 to the third power. So this is something that's special, and the reason we use scientific notation in science is because scientific notation only shows significant figures and gets rid of everything else. So in scientific notation, however many numbers there is before the times 10 to the x power is how many significant figures there is. Everything before that will always be significant. So now we know how to tell how many are in any given number, but whenever you do math with significant figures, things change a little bit. You have it, and there's two separate categories. You have addition, subtraction, and multiplication, division. In addition, subtraction, your measurement is only as precise as the least precise number. So what does that mean exactly? You've got, say you have a number like this, 15.3 plus 10.205. The most precise one is the 10.205, right? That's measuring to the thousandth place, 3 after the decimal. But you also have 15.3, and that's only measuring to the 10th place. So when you're looking at it, the 10th place is less accurate, or less precise than the 1000th place. So when you just add them together, the number you get is 25.505. But when you take into account significant figures, and that the first number, the 15.3, only goes to the 10th place, then your answer is only going to go to the 10th place. And your significant figure answer would be 25.5. Multiplication division is a little bit different. Your answer will have the same amount of significant figures as the number with the least amount of significant figures. So an example here is 8 divided by 5.302. If you punch that in your calculator, you get that long number, right? 1.508864579. But you have to break that up, and you say, oh, there's only 2 significant figures in 8.0, and there's 4 in 5.302. So since 2 is less than 4, you're only going to have 2 significant figures in your answer. So your final answer would be 1.5, with the 1 and the 5 being significant. So here's some more practice problems if you guys want to do those. If you think you need more, and if you have any questions over those, you can email me. And there's plenty of practice problems online that you can go over. This has been Significant Figures.